Okay, what we're going to be learning today is how to predict the products of a chemical reaction from the first half. We're going to start out with words or the names of the compounds on the first side. And I actually think it's a little easier to do this way because you have to get your charges and stuff first. Your assignment you're going to do actually gives you the formulas of the first half, but you can still do it. Okay, so we're not going to end up doing all of them on the sheet. We're going to do a smattering, selected ones. All right, so let's take a look at this first one. Okay, magnesium bromide plus chlorine. All right, what's the symbol of magnesium? Mg. And what's its charge? +2. Very good. Bromide is going to be just bromine. What's the symbol for bromine? Br. And what's its charge? -1. Very good. Which do I need more of? Bromine. How many bromines do I need total? 2. So MgBr2 plus chlorine. If chlorine's by itself, how do I write it? Cl2. It's one of our H Broncliffs. So if they're by themselves, they have to be 2s. All right? But just so we've already got it, what kind of charge does chlorine have when it's in a compound? -1. Very good. So can chlorine combine with bromine or can chlorine combine with magnesium? Magnesium, because opposites attract. Okay? So we draw our yield. Okay? And so chlorine's going to go in there, and it's going to be with magnesium. We always write the positive component first. Okay? Which one do I need more of? Chlorine or magnesium? Chlorine. How many chlorines do I need? 2. Plus, who's left over? Who got kicked to the curb? Bromine. How do I write bromine? Br2, because it's one of our H Broncliffs. Okay? And this one is already balanced. Right? Okay. Before we go on, what type of reaction is this one? Very good. It's a single replacement. Wow, it's almost like I coached you up, but I didn't. And then is it the positive or negative thing that gets switched out? It's anionic. Single replacement, anionic. It's the negative one. Good, good. I heard some of you get it right away, and I was waiting for more. So that's what. So I wasn't ignoring you. I was just letting everybody get there. All right? You guys good on that one? Does that make sense how we predict them? You guys are like actual chemists when you can do this stuff. I mean, really, that's part of your, now, again, we're at the very basic level, but that's part of what they do. They're able to kind of, well, if I do this and this, yeah, I get this. Does that make sense? All right. Okay, let's go ahead and we're going to do number 2 together. But I'm going to switch pen colors because, it's fun. All right. Number 2, aluminum. What's the symbol for aluminum? Al. All right. And let's go ahead and write its charge above it. What's the charge for aluminum? +3. Even though it's by itself, we're just going to have it for the second half. All right. Plus iron 3 oxide. What's iron symbol? Fe. What's its charge here? +3. Okay. All right. And then oxide, what element's that going to be? O. And what's its charge? I heard it. -2. Very good. All right. What do 2 and 3 both go into? 6. How many irons do I need to make 6? 2. How many oxygens do I need to make 6? 3. All right. Okay, so aluminum's by itself. Can it combine with iron or oxygen? Oxygen, because, what do we say? Opposites attract. Opposites attract, okay? All right, so aluminum with oxygen. Aluminum's 3 and oxygen's 2. What do they got to go into? 6 again, yeah? Just like it's kind of the same pattern, all right? So how many aluminums? 2, yeah? And how many oxygens? 3. And who got kicked to the curb? Iron. What kind of reaction is this one? Single replacement cationic. Very good. I heard somebody go straight to it. Nice job. Do you guys see that? Yeah. All right. That's a very good question to go back and review. All right. It's whoever gets kicked out. Up here, the bromine's the one that got kicked out. It's negative, right? So the bromine, that makes it anionic because anions. All right. In this one, iron's the one that got kicked out, right? Iron is positive 3. So since it's positive, it's a cationic one. All right.
Mr. Beeman, what happened to the +3 on aluminum?
So on this side,
Yeah.
you don't show it when it's by itself. It doesn't have a charge yet. We went and wrote it so that we know who it's going to combine with. All right. But then when we went over here, 2 times +3 is 6. 3 times the -2 is -6, so it balanced out. Yeah. All right. That's a good question, guys. When there's an element by themselves and we're doing the predicting, I go ahead and put the charge not in the equation, but with the name or wherever it is in the problem, so it helps me to figure out what it's going to go with. Okay? All right. Okay, let's look at this next one. Silver. Oh, what color should I use now? Pink or green? Let's go green. I think pink wouldn't show. Oh, we do have to balance it. You're right. I forgot to. Okay? All right. Let's see. Aluminum's over here. I got 1. Iron, I got 2. Oxygen, I got 3. Here, aluminum's, I have 2. Iron, I have 1. And oxygen, I have 3. So what's not balanced? Aluminum and the iron. Okay, but the oxygen's good, isn't it? All right, so how would I balance my iron? Put a 2 over here. All right, and that makes that 2. And then how would I balance the aluminum? And do what? Yeah, same thing. We're going to put a 2 in front of the aluminum and make that 2. But we don't have to do anything to the compounds. So 2 aluminums plus Fe2O3 gives me Al2O3 plus 2 irons. Good question, guys. Sorry. Sometimes when I'm recording, I get so focused on getting through all the problems, I forget to do everything. Thank you. All right. Okay, silver nitrate. What's the symbol for silver? Ag. What's the charge for silver? +1. Very good. Nitrate, element or ion? Ion. What is nitrate? NO3. We use that one a lot, so maybe that's one you memorized. And what's its charge? -1. Okay, so they're just going to cancel, aren't they? +1, -1, so it's just AgNO3 plus zinc. What's the symbol for zinc? Zn. What's its charge? +2. Chloride. What's the symbol for chloride? Is that an ion or an element? Element. And what's the symbol for it? Well, it's one, and it's Cl. All right. Which do I need more of? Cl. What would I write the formula? ZnCl2. Very good. All right. Who can silver end up with? Chlorine. Because if it stayed with nitrate, we didn't have a reaction. So silver's going to go with chlorine. Right? Opposites attract. So Ag +1, Cl -1. How do I write it? AgCl. Very good. Because they're going to cancel each other out. Plus, who's zinc going to end up with? Nitrate. Zn and NO3. What's charge of zinc? 2. What's charge of nitrate? -1. Who do I need more of? Nitrate. Remember, if it's a polyatomic ion, we got to put parentheses around it. How many nitrates do I need? 2. Okay. Are you with me? All right. So over here, Ag, I have 1. NO3, I have 1. Zn, I have 1. And Cl, I have 2. And guys, if you're doing this on your own or whatever and you need more space, use scratch paper. All right. Over here, Ag, 1. I'm going to do it in the same order. 1, NO3. Oh, not 1 on NO3, 2 on NO3. Zn, 1, Cl, 1. So what are not balanced? The NO3 and the Cl. Okay, good. Yeah, the NO3 and the Cl. Okay. So what do I need to do to get my NO3s balanced? 2 in front of the silver nitrate. Very good. All right, that makes my silvers 2 and my nitrates 2. Okay. All right, and then how do I balance my silvers now? 2 in front of the silver chloride. Okay, makes it 2 and makes my chlorines 2. And that took care of it, didn't it? That balanced everything now. Are you with me? Okay, real quick, because the question comes up. Could I have written this as AgNO3 plus ZnCl2 gives me ZnNO32 plus AgCl? Yes. As long as you put the right components together, you can switch them on the pluses. Does that make sense? So I could have wrote this compound first and this one second. Are you with me? Okay. Now, if you write the negative thing first, you'll lose half credit. Is that what you're going to ask?
No, I was gonna, it was on number 2 actually.
Oh, okay.
Whenever we had the aluminum, why didn't we have 2 of those? Because like, on the chlorine, on the first question was 2.
Oh, it was Cl2, but with the aluminum, it's just Al. Okay, so remember H. Broncliffe. That was one of the things we learned way back in the day. These elements, these 7 elements, when they occur naturally, they're always in diatomic molecules, 2s. All right? So if we just have any of these, nitrogen, it's N2, right? You go to Costco and fill up your air with tires, or your tire with air, you fill it up with nitrogen, it actually says N2 on their little pump thing. All right? You go to the hospital, they put you on oxygen, a lot of times it says O2 on the dial. All right? So, but for every other element, for what we're going to deal with, it will always, if it's just the element, it'll be 1. In the college class, we learned like phosphorus is one of its natural states is P4. Sulfur is either S6 or S8, but sulfur can also just be S. So for everything, especially this class we're just learning, we need to know the diatomics. Everything else we're just going to leave as 1s. Okay? And they'll work out. All right. That's a good question. Little reminder. All right. We're going to do number 4, and then we're going to skip down and do, we'll do 4 and 7, and then I got 2 I wrote on the back. Okay. Hydrogen peroxide. We've talked about this, but we haven't really written it. Look on your pink sheet. What's peroxide? It's in the second column. O2, but what's its charge? -2. The whole thing is -2. Okay? And hydrogen is H with what charge? +1. Okay? Hydrogen with a +1 charge. So, so we got to have H2O2. That's hydrogen peroxide, like you use to clean out a cut. That's what it is. It's not very stable. Now, this is saying it's catalyzed by magnesium hydroxide. We don't even need to know that. It can also be broken down by a light. That's why it's got to be in a brown bottle. If you want to do a little experiment, pour a little bit in a clear glass, set it in the window, and you'll see little bubbles form. That's oxygen escaping. All right? It breaks down into H2O and O2. All right? But for us, anytime we have just a compound, it's going to be what kind of reaction if we only have one thing on the left? Decomposition. All it can do is break apart. I'm not going to make you memorize because we just don't have time. All the little special, if it's this, it's going to do this. If it's this, we're just going to say if it's in a compound, we're going to split it up into its individual elements. All right? You go on and take the college class. There's a few of these special ones we'll learn, but even that, guys, there are gazillions of little special decomposition things. There's no way to know them all. All right, there's just not. So for us, we're just going to say, hey, if all we have is a compound, we're going to split it up into its elements, hydrogen and oxygen. But if we have hydrogen by itself and oxygen by itself, how do we write them? Yeah, H2 and O2. Very good. Yeah, otherwise they're unstable. Can we force that? Yeah. That's how a fuel cell works. They actually have a way they catalyze it and cause the hydrogen to split apart, but it don't like it, so it comes back together, and that's where they get the energy. All right? That's all you got to do on that one. If you have and what kind of reaction would this be? Decomposition. Okay, decomp. All right. Oh, I forgot to say, what kind of reaction was number 3? That's a double replacement. Very good. Okay, we're going to skip 5 because it's another single. 6 is another double. We're going to go down to 7. All right? You guys ready for 7? Oh. Look, I'm like Taylor Swift. Are you ready for this? No, not funny. Dorky funny? Dorky funny. Okay, I'll take that. All right, sodium. What's the symbol for sodium? Na, and if it's by itself, it's just Na. All right, plus hydrogen. What's the symbol for hydrogen? H. But if it's by itself, H2. All right, so we have 2 individual elements. It's the only thing they can do? Do what? Combine. What do we call that? Not combustion. Synthesis. Some text and stuff will call it a combination reaction as well instead of synthesis. Synthesis is how I learned it, so that's how I teach it. All right. Now, this is where it's a little weird. Sodium forms what kind of ion? What charge? +1. Hydrogen normally forms what kind of charge? +1. But those of you guys that wrote this stuff on your periodic table back in the day, what's the other charge I had you write for hydrogen sometimes with a little arrow? You should have a little arrow with another charge next to hydrogen. You don't have it? Okay, if not, you can write it now. It can sometimes be -1 whenever it combines with a metal. All right, hydrogen's a weirdo. It does all sorts of stuff that's just different from all the other elements. It can go and do either way. All right? So if I have Na plus H2 plus 1 minus 1, how would I write it? Na and then just H, sodium hydride. And when we have it that way, we call it hydride. We don't say hydride, so it'd be sodium hydride. All right? Is it balanced? No. So let's see. I got Na, I got 1. Hydrogen, I got 2. Over here, I have 1 and 1. Which do I need? What do I need to do? I need more H's, so what I got to do over here? 2 on NaH. That's going to change my H2, but it also changes my Na. So what else do I got to do? Put a 2 on the Na. All right? Are you with me? Okay. We're not going to do this one right now, but I do want to show you. Copper. What's the symbol for copper? Cu. Okay? What is its charge if you look at your periodic table? We don't know, right? It's one of those ones they have to tell you. If I give you one of these on the worksheet, I will tell you, oh, copper will be +1 or +2 or whatever it would be. Okay? All right. And you'll see that actually on our worksheet today. I think it's with iron. I give you that charge. All right. Now flip it over. I wrote 2 more on the back. Oh, can you guys see that? Yeah. All right. Okay. C5H12 plus O2 and C6H12O6 plus O2. All right. Oh, let's see if pink shows up. All right. It's a what? Both of them are combustion. Nice job. All right. How do I know it's combustion? Because I have a hydrocarbon plus oxygen. For some reason on the test, these are the ones that if people get everything right but only miss 1 or 2, they'll miss this one because like I thought it was a single replacement. It kind of looks like a single replacement, but it's not. It's a combustion. What are always going to be the products for combustion for us? Yes? CO. What? CO2 plus H2O. Carbon dioxide and water. All right? If I see C something, H something plus oxygen, I'm like, bam, I got it. CO2 and H2O. So this one is even a little bit more complex. It's C6H12O6 plus O2 is going to give me what? CO2 and H2O. Right? Yes, Mr. Beeman. All right, cool. All right. Now we go through and balance it. CHO, it spells Cho. That was Harry Potter's girlfriend for a little while. Right? Cho Chang? Yep. All right. 5, 12, and 2. CHO. 1, 2, 3. Oh. Is that right? Yeah. For some reason I didn't add right. Okay. So now, here's the way to shortcut and see if this is going to be a complicated one. What's half of 12? 6. Is that even? Yep. If it's even, I don't have to double it. If it was, let's say this was 10 instead, what's half of 10? 5. Is that even? No. So I would need to double it. That way you don't have to go through the steps to get that part. If you don't remember it, just go through the steps, and if you get stuck, go, oh, I got to double it. All right. So if I have 5 here and 1 here, what do I got to do? 5. That changes my C's to 5, and then I have 10 plus 1, 11 oxygens right now, right? I have 12 here. What do I got to put in front of the H2O? What do I got to put in front of the H2O? 6. All right. And that's going to make that 12, and then 6 oxygens there. What's 6 plus 10? 16. So what do I got to put in front of my O2? 8. That makes that 16. Everybody happy, happy, happy. All right, let me show you this one. This is the reverse of photosynthesis. This is what happens in our cells and why we produce carbon dioxide. Yeah, that's what happens. The oxygen comes in, it burns with our sugar and gives us carbon dioxide and water. That's why we breathe out carbon dioxide and we have to go potty. All right? Okay? I mean, it is. All right? So, CHO. This one's a little trickier because we have O in 2 places on both sides. So this side is always 1, 2, 3. This side is 6, 12, and then how many oxygens on the left? It is 8. Good job. All right. So we just go through it the same way. What do I got to put in front of my carbons here? What? 6. Very good. So 6, and then the oxygen is 12 plus 1 is 13. All right. And then what I got to put in front of my hydrogens? Another 6. That makes that 12. 6 times 1 is 6 plus 12 is 18. Now, this is where you got to be careful because normally we just put a number in front of this O2, but we already got some oxygens here. Right? Yeah. So take your 18 minus 6. What's that equal? 12. How do I make this 12? What I got to put in front of it? Now I got to put another 6 there. All right. That makes this 12 plus 6 gives me 18. Everybody happy, happy, happy. Correct? Okay. So now you have all of the knowledge to be able to do the backside of this worksheet. All right. Do your predicting and balance them and say what type it is. And notice on this one, it says iron will be plus 2 on the opposite side. All right. On these two, they are ones that have multiple charges. Their charges will stay the same. So whatever their charge is on the left side, it'll have the same charge on the right. You just have to figure it out. Okay? Get this puppies done for tomorrow. Hang on just a second. Command. Oh. Hold on.